Okay, hi guys, Noddy here with another tutorial. I'm going to talk about Power over Ethernet today. Now what's brought this about is that I've gone and bought myself some second-hand Cisco 7940 series desk phones, which look pretty good. I was able to get them for about 40 bucks each to hook into my 3CX PABX system. Now the problem is, of course, it's all well and good to buy phones for $40 each, but the power adapters to run these damn things are actually about $40 or $50 per power adapter. So I needed to come up with a way to get power to these phones without having to shell out all that cash. Now, these phones are designed to use Power over Ethernet, so I'm going to just have a talk about what I did to get it going. Now, just in general, Power over Ethernet, it's about putting 48 volts down the Cat5 lead to power devices like phones and cameras and so forth. Now, it's pretty handy if the power can come to the phone, because it saves you having to have power packs everywhere, tying up power points. Saves you the cost of buying the adapters for each device, and just saves on mess, because you just got one lead going to your device rather than the Cat5 lead plus the power. Now this is a photo of the front and back of a Cisco 7940. You see the photo on the left, all running beautifully. It's getting 48 volts down the line, and it's just got that one lead going into the back of it. So on the 7940, it's that middle socket which is entitled 10/100 switch. Now with this you can run another lead from that phone over to your PC, just to save having to run multiple cables, which is pretty handy. If you can't get Power over Ethernet going, you'll see behind that Cat5 lead where my cursor is, it's actually got a 48 volt socket input, but obviously we're trying to get away from that. Now, with when I went to do this, I had a lot of trouble finding out what wires do what. So I've worked it all out for you. Turn the Cat5 plug on this angle as shown, where the pins are up and the little plug at the bottom is down, and put it on this angle as you see here. Pin 1 is at the top and pin 8's at the bottom. And this is the wiring combination. Now, just while I'm talking about it, it's standard Cat5 wiring, so it's not any different from your standard Cat5 lead in terms of the colours and the wiring and the way it's done. So now it turns out you've got 8 cables inside of your Cat5 lead, and like 8 individual cables. It seems that computers and all that really only use 4 wires out of the 8, and so what you got is pin 1, 2, 3 and 6 carry the data, and then in a normal situation pins 4, 5, 7 or 8 are actually unused. So instead of them being unused, we're going to put power down them. Now on the 7940 series, that's an old standard, so that's, as you see it there, that is the like pin 4 and 5 carry the negative, and pin 7 and 8 carry the positive. However, you need to note that on newer devices it's in reverse, so I think you'll find that the positive goes down pins 4 and 5 and the negative will actually go down pins 7 and 8. So this is a setup I put together. It's a bit rough, but who cares, it works, it's beautiful. Down on the left there is 3 Cat5 cables coming onto the board, and I've zip tied them on there. That's for 3 phones that I have running. So these Cat5s go to around the house to the other phones. In other words, the end of that Cat5 goes into the ends of the phones, the other end. Now what I've done is I've simply split the power and the data. So the data, which is 4 wires on each Cat5, goes into a network hub, and the network hub actually will get linked into the rest of the network. And then up here on the right is the power. I've just got a simple little wiring strip, and I've just what you'll actually see here on the back of the board is a 48 volt plug pack. It's a high capacity one. It's about 1.4 amps I think, and that simply supplies the power to that terminal strip, and then it goes down the Cat5 cables. So to build that, what you're going to need is a piece of timber, a cheap network switch. I bought mine for about $15 on Gumtree, and it's an 8-port. So you just need to make sure you've got enough sockets for the amount of devices you're going to connect. You want to get yourself a high capacity 48 volt DC power supply, which is going to step down the voltage from 240 down to the 48 volts we need. In Australia we have limited places to buy this sort of stuff, and I was able to get one from JCar. Now you'll need Cat5 cable and Cat5 plugs, and then you'll also need the tools to join all together, which is a crimping tool, the screw terminal strips, and then you're going to need zip ties and all that to attach it to the timber. Now the advantages of the splitter board, really the main advantage is you don't have to go and buy individual plug packs, and you don't have to have the hassle of having them tie up all the power points in the house. But you see, like that one 48 volt power supply that's on my board, it'll run a good probably 5 phones, and considering they're normally $40 to $50 per adapter for the genuine Cisco one, you know, it's worth doing it this way. Now there's some more wiring combinations and standards information on that website, and if you want to email me any questions, I'm happy to help you. Okay, see you later.